Good morning, boys and girls. This is Mr. Brown coming to you from the Floyd Middle Magnet School Digital Online Campus, also coming to you from my roof. Now, I know what you're thinking. Mr. Brown, don't do it. You're far too valuable to the Floyd Middle Magnet School. You're far too handsome to jump off this roof. Boys and girls, I'm not jumping off this roof. I'm living my best life. I'm having fun. And today, the reason specifically I'm on the roof was we are talking about slopes and rates of change. And what better way to demonstrate a slope but to sit on one? All right, slope is the measure of the steepness of a line on a graph, but it's also the measure of how steep your roof is. It's called the slope of the roof or the pitch. If you're on a bicycle and you're fat like me and you're going up a big long hill, you start to think about the steepness, the slope of that hill. These are all real world examples of when we use slope in real life, right? So now let me try to carefully get off this roof so that we can continue the lesson inside number one where it's not as hot. And you know, there might be some coronavirus people around here somewhere. Let's get inside where it's safe. Woo! I had to come down off the roof. It was scary up there. All right, like I said, we are going to talk about slope today. Slope is a measure of the steepness of a line or a roof. The measure of the steepness of a line on a graph is what we're going to focus on today. All right, it is the ratio of rise, that means how far it goes up and down, to run, that means how much it goes from side to side. So the formula for slope is slope equals rise over run. Okay? In other words, the amount of vertical change as compared to the amount of horizontal change. All right, so again, how much does it change up and down over how much does it change side to side? A lot of times slope is written as a fraction. All right, so what I have done here is I have given us a line on a graph, and I want us to find the slope of this line, line AB. All right, so again, the slope is going to be the rise over the run. Okay, so we pick one of our 2 points. Let's pick A, and we count how many vertical units we change to go from A to B. Well, all you have to do is move up 1 space. All right, so up 1. Does that sound like a positive 1 or a negative 1? That sounds like a positive 1 to me. And then from there, we handle the run, the horizontal change. How many spaces do I have to scoot over to get from where I was? All right, well, that would be 1, 2, 3 spaces to the right. So 3 to the right, does that sound like positive 3 or negative 3? That sounds like a positive 3. But, Mr. Brown, what if I had gone from point B back to point A? All right, let's see what happens. If I want to go from the point B to the point A, I would go down one space. Well, what does down one sound like? That sounds like a -1. And then I would move to the left 3 spaces. To the left 3, that sounds like -3. So which one of these two things is correct? Well, a negative divided by a negative is a positive. So both of these things equal the same amount. 1/3 and -1 over -3 are the same thing. So it doesn't matter if I track this going from A to B or from B to A, it's still going to give me a positive 1/3. All right, there's a little bit of a hint visually as to whether or not the answer is positive or negative. If a line rises from left to right, like this one does, all right, we're going up as we move left to right. If a line or if a slope rises from left to right, its slope is going to be positive. Okay, I knew that one was going to be positive before I even counted because it's going up left to right. Now, if a slope or a line falls from left to right, then its slope is negative. All right? So, there are 2 other things we need to be on the lookout for, but these are our 4 types of slopes. All right? The first type of slope we're going to talk about, or we're going to write down, is a positive slope. Okay? Not being very specific here, but if this line is going up left to right, so like this line right here. All right, because that line is going up as it goes left to right, this slope is positive. Now we would have to get in and count to see exactly what it is, but I know it's positive because it's going up left to right. If my line, and again, it doesn't matter what degree of a slope it is, if it's going down left to right, like this line, I don't know what it is specifically, but I know that it is going to be negative. All right, well, what else could there be? Well, what if we had a line that was parallel to the x-axis? All right? If you were on a road that looked like this, and I asked you, what is the slope of the road that you're on? Well, this road is not going up or down, right? So the slope of this road is 0. Or you could say that there is no slope to that line, okay? If the line is parallel to the x-axis, if it's straight left and right, then it has a slope of 0 or no slope at all, okay? The last one that you have to be on the lookout for is a vertical line. If your line is vertical, parallel to the y-axis, this is the one that's wonky. You would say that this slope is undefined. Okay? Positive slope goes up left to right, negative slope goes down left to right. If it's straight across horizontally, the slope is 0. And if it's straight up and down, parallel to the y-axis, then the slope is undefined. Before we go too much farther in finding the slope of a line, let's review fractions that are equivalent. All right, for example, what is equivalent to 2/5. Now, I'm not talking about changing it and making it 4/10 or 6/15. I'm talking about, as far as positives and negative goes, what is equivalent to 2/5. All right, well, these are both positive, so when you divide, you get a positive number. All right, well, just like on the front of this sheet, if we have both of them as negative, a negative divided by a negative is also a positive. So these two things are equivalent. Well, what about when it's negative? All right, first of all, -2, if you're dealing with slope, you want a rise and a run. You want a numerator and a denominator. So we could change this to negative and then put 2 over 1. All right, well, which one of those is actually negative? Well, you could have either of them be negative. They can't just both be negative, because if they're both negative, then it's actually positive, and that undoes the negative. All right, so there are two ways I could rewrite -2 over 1. I could put the negative on top and do -2 divided by +1. Or I could put the negative on the bottom and do +2 divided by -1. All right, all four of these things are equivalent. And that's some good stuff to remember as we move forward with slopes. So now we're going to get into actually finding the slope of a line. The instructions for these two problems say to tell whether the slope is positive or negative, then find the slope. So there will be two answers here. All right, first let's look at letter A, this line AB. All right, what did we say about a line that went up from left to right? Hopefully you remember that we said that that was a positive slope. Okay, so there's our first answer. Now we actually have to find the slope of this line. So you pick one of the 2 points. It doesn't matter which one. Either way, the answer should wind up being positive. Let's go from the A to the B. All right, so to go from A to B, remember with slope, you want the rise, the up and down first, over the run, which is the left to right. So if I'm going from A to B, first I would move up 3 spaces. So that would be a +3. And then I would move to the right 3 spaces, which would also be a +3. And 3 divided by 3 is 1. So the slope is 1. And just for argument's sake, let's say I went the other way. Let's say I went from B to A. You don't have to do these both ways, but I want you to see it both ways so that you know it works out to be the same. So to go from B to A, I would go down 3 spaces. So that would be a -3. And then I would move to the left 3. Left 3 would also be -3. Well, -3 divided by -3 is a +1. All right, so we get the exact same answer both ways. All right, so it was a positive slope and we got a +1. Look at letter B. All right, letter B is going down from left to right. What kind of slope goes down from left to right? That would be a negative slope. All right, so whatever number we come up with here, it should be a negative. So again, slope equals rise over run. And let's go from, it doesn't matter, let's go from C to D. So first we would have to go down 2, 4, 6, 8 spaces. So down 8 would be what? -8. All right, but we're not to the D yet. We also have to go to the right 2 places, right 2 would be a positive 2. And then negative 8 divided by 2 would give us negative 4. Now, both of those worked out to be integers, but that is not always the case. Sometimes you get a fraction that cannot be simplified. Okay, but those just happen to do. All right, so we got a negative slope because it's going down left to right, and we wound up with a negative slope. So those two things should agree with each other. One of the things that is going to be very important that you learn how to do here at the end of 7th grade and going on into 8th grade is to graph a line. So what these next couple of problems are going to do is they are going to ask you to take a single point that is on the line and the slope of the line, and they want you to graph the entire line that has those two things. So we are going to break this into 4 simple steps. Step 1, you are going to graph the point that they give you. All right, that should be easy. All right, so if they tell you to start at 5, 4, move to the right 5, move up 4, and put a dot. That simple. The second thing that you are going to do is to use the slope that they give you to graph at least 2 more points. Okay, so you started with the one that they gave you. You need 2 more, so that's at least 3 points to draw your line. It's important that you get 3. It makes your line nice and straight, and it's what I'm going to require you to do. Step 3, and this is the hardest step of them all. Take a ruler and draw a line through. Take a ruler very carefully and draw a line through all 3 of your points. Let's put this down. That's dangerous. All right. And then step 4 is to put just little arrows on the ends of your lines to indicate that that line extends forever in those 2 directions. All right. Real simple. Graph the point that they give you. Use the slope to graph at least a total of 3 points. Then very carefully use a ruler to draw a line through all of your points and then put arrows on the end. I'm going to show you with these next 2 problems exactly how to do that. All right, so take good notes, follow along. Here we go. All right, so here is a problem that asks us to use the given slope and point to graph each line. So they've given us a slope, negative 3/4, and they've given us a point on the line, negative 3, 2. And then here were the 4 steps that we just talked about. The first thing we're going to do is graph the point that they gave us. So negative 3, 2. All right, so from here, negative 3, 2. All right, so that was the first step. Check. The second step is to use the slope to graph at least 2 more points. So we should have a total of 3 points or more by the time we're done. All right, so we got negative 3/4. We've got some options here for negative 3/4. So for negative 3/4, we can use negative 3 over positive 4, or we can use positive 3 over negative 4. All right, let's start with this negative 3/4 and see if we can't get all of our dots from that. All right, so from the point that they gave us, negative 3/4 means we're going to go down 3 and to the right 4. So down 3, right, 1, 2, 3, 4. We'll put a dot. Then we're going to do that again. Down 3, right 4, boom. All of your dots should line up. If not, you did something wrong. You need to go back and look at it. All right, so use the slope to graph at least 2 more points. Boom, check. Next up, draw a line through all of the points. So you take your ruler and we line up all 3 dots on the ruler and we draw a line. Okay? So draw a line through all the points. Check. Draw arrows on both sides of the line. This shows that the line continues on forever in those 2 directions. All right? Easy. If we just follow these 4 simple steps. All right? All right, here is another one that comes with the same directions that we got last time. Use the given slope and point to graph each line, to graph the line. All right, well, let's talk about this slope of 3. All right, we need a rise and a run. So we need to put something underneath the 3 that still leaves it a 3. Well, what about a 1? All right, so we can go up 3, right 1, or if we need to, if space does not allow us to do that more than once, we could go down 3 and left 1, because a negative divided by negative is still a positive 3. So we start with the point that they gave us. -1, -2. All right, that was step 1. Step 2, use the slope to graph at least 2 more points. All right, let's use this +3 over +1. So +3, +1 would put us here. And what if we wanted to use this other one for our 3rd dot? Well, we would go down 3, left 1, and that would put the dot right here. But again, if you look, it still lines up with all of the points that we had already graphed. And we take our ruler, we draw a line through our points, and we put arrows on both ends to indicate that that continues forever. All right, look at what we've got. If we go up 3 over 1 again, up 3 over 1, boom, still on the line. Up 3, right 1, still on the line. Okay, that's the whole point of a slope, is it gives you every single dot on this line. Okay? All right, we're going to keep moving. The ratio of 2 quantities that change, such as slope, which is what we've been talking about, is called a rate of change. All right, and there are 2 main kinds of rates of change. The first is called a constant rate of change. A constant rate of change describes changes of the same amount during equal intervals, such as a linear function. In other words, constant rates of change show up as straight lines. Okay? So if you had this graph right here, that is an example of a constant rate of change. Even if it's negative, this is still a constant rate of change. It doesn't even have to be that dramatic. Even if it barely slopes up at all, if it is a straight line, that is an example of a constant rate of change. So all 3 of these are examples of constant rates of change. On the flip side of that is what is called a variable rate of change. All right, and a variable rate of change can show up in many different forms. You could have a curved line. Okay, this is an example of a variable rate of change. The line could be straight, and then partway through your graph, change to a different slope, that is also an example of a variable rate of change. One very common variable rate of change is an exponential curve, all right, where it starts real close down in here, but then starts to get bigger and bigger and bigger and bigger and curves up, all right? All three of these are examples of variable rates of change. So what I'm going to do now is I'm going to give you three graphs, and I want you to decide if the graph shows a constant rate of change or a variable rate of change. Let's look at letter E. All right, we've got our coordinate plane, and look at our graph. All right, is that an example of a constant rate of change or a variable rate of change? It is a constant rate of change because it is a straight line, one straight line with the same slope the whole time. All right, letter F. You got your coordinate plane. Is that graph an example of a constant rate of change or a variable rate of change? It is a variable rate of change. All right, curved lines fall into the variable rate of change category. All right, letter G, you got your coordinate plane, and then look at this graph. All right, yes, these are straight lines, but do they all have the same slope? No, some of the slopes are positive, some are negative, and it keeps changing. This is an example of a variable rate of change. Okay, very easy to tell the difference between a constant rate of change and a variable rate of change. Constant rate of change is a straight line. A variable rate of change will have a curve or bendy parts to it, and that makes it a variable rate of change. And finally, of course, we always got to bring it back to a real world word problem. So I've been playing a lot of Animal Crossing lately. So I eat, breathe, and sleep chasing butterflies. If you play Animal Crossing, you know exactly what I'm talking about. So let's do a problem, a math problem that revolves around a video game. Math and video games? Can you believe it? How much fun can one person have? Let's see. Last up, let's look at a problem about a real world situation. All right, this graph shows the distance a monarch butterfly travels over time. Tell whether the graph shows a constant or variable rate of change. We can do that. Then find how fast the butterfly is flying. All right, there are two parts of this. The first part is to tell if this graph is a constant rate of change or a variable rate of change. What do you think? Hopefully you think it is a constant rate of change. How can you tell? Because it is a straight line. Number two, they want us to find how fast the butterfly is traveling. In other words, what they are asking us for is the slope of this graph. So, how do you find slope? Slope is rise over run. All right? So, we're going to pick any 2 points on this graph. Okay, let's say we go from, we want somewhere where the light blue lines intersect. So what about from like here to here? What if I call this one X and this one Z? Okay, so to get from X to Z, first we have to rise. We're going to go up. Now you might say 2, but if you look over here at your intervals, each one of these lines represents 20. So if we went up 20, 40, we went up 40, and what was that? Miles. And then how long did it take us to go up 40 miles? It took us, and if you look down here, these are by ones. So it took us 2 hours. All right. And we could simplify that. 40 divided by 2 is 20. The miles is on top. Per, the hours was on bottom. So this monarch butterfly flies at 20 miles per hour. And I don't know how many of you have been playing Animal Crossing here recently, but sometimes those butterflies fly real fast and they're hard to catch. Who's with me? All right, there you go, boys and girls. That's your lesson on slope and rates of change. I hope you had a little bit of fun today. Hope you took some good notes. Tomorrow is Thursday. You will get a practice sheet using these same skills that we learned today on your own. As always, I will provide an answer document with the correct answers and the correct lines drawn on the paper. So please, once you have completed the sheet by yourself, use my answer key to check your answers, the answers that you got by yourself. Don't cheat. You know me. All right. Friday, we are going to have a daily grade covering the coordinate plane and what we learned Monday and Tuesday, and slopes and rates of change, which we talked about today. All right. So study, look over your notes. If you need to watch one of the 2 videos again, go ahead and do it. All right. Don't forget to, on this video, to like, comment, and subscribe. Some people not liking, some people not commenting, and some people not subscribing. All right. And if you're really smart, you'll ring that bell, ring a ding, 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 so that you know every time Mr. Brown drops a new video on YouTube. For my boy SpongeBob here, I'm ready. All right. He wants to say, hey, what do you want to say, SpongeBob? Um, Stay safe and don't do drugs. Well, you heard it from my man SB and from Mr. B. You guys stay safe out there. All right, bye.